Okay, here's the problem. Um, I was a good student in high school. Well, I was a horrible student in high school. Then I became a good student in high school. Then I got to college. I was a very good college student. I loved college. Anyway, I've been a high school kid. I've been a college kid. My job now as a teacher is to get a bunch of high school kids up to college level. And a lot of that is about how you think, and a lot of that is about how you write, and a lot of that is about how comfortable you are with math. But when it comes to chemistry, it's a long reach. There have been changes in how we teach chemistry at the high school level. And we've been teaching it to increasingly younger students, and we really changed those standards. So high school chemistry is like this, and then college chemistry is like this. And it's a big reach. I got to get all of you to be competitive with, to be at the level of college kids. And I'm not qualified to teach chemistry, and we don't have the time to do all of that. So I've made a couple of band-aids, and I'm going to start super simple. I know what happens. A bunch of kids are like, screw this. I'll just skip this part. This class is all right. But, kids will decide I'm going to ignore this content. And I have to warn you, you cannot afford to do that. There's a lot on the AP exam about nuclear energy, nuclear power, and the chemistry. And we can do it. I swear. I have just a few little details. I can get you from zero to hero, and all you need to do this, it's a few slides. Bear with me. BandAid number one is about the atoms. Atoms are made of little parts. Those little parts affect the behavior of an atom. You've heard all this. We're going to start easy. And I want to end this band-aid with you comfortable with numbers, atomic number and atomic mass, just numbers. That's all we're going to talk about. So maybe you've heard about the Bohr atomic model. This should have happened sometime in middle school and probably came up again sometime in high school. There are negatively charged electrons, which are really tiny. They zip around the outside. They used to teach that they were in rings. If you're really good at chemistry, you realize that they're like probability clouds. Anyway, don't worry about them. Electrons, negatively charged. And this is chemistry 101, so that's all you need. Negatively charged electrons. They flip around the edges. They're very, very small. There's also positively charged protons inside the nucleus, and there are uncharged neutrons. Neutrons are neutral, protons are positive. So far, so good. By the way, there's fascinating forces at play. When you become a nuclear physicist or a nuclear chemist, then you're going to pay attention to the magnetic attraction between the positive and the negative, the inertia, and the kinetic energy of those moving parts, and the gravity, what holds all those together. We'll talk more about those forces at a later time. There's your parts again, proton, neutron, and electron. And I'd like to identify two numbers here. The atomic number is the number of protons. That's what makes it an element, is how many protons. So if you have element number one, that means one proton. And if you have element number two, that means two protons. And if you have element number 92, that means 92 protons in the nucleus of that atom. So when we say elements, what we are actually describing is the number of protons. Okay, so anything with 92 protons would be the same element, element number 92. That's called the atomic number. It's the number of protons. You absolutely have to know that. That was our goal for this little band-aid. Was the atomic number is the number of protons, and the atomic mass is the protons plus the neutrons. We don't really count the electrons because they're so light, they really don't matter. You can basically ignore them in terms of the mass, the weight. Okay, so we're doing good. You can make this thing called a periodic table. which shows you some of the properties, because when you have a certain number of protons, you're going to get a certain number of electrons, and that number of electrons will affect their bonding behavior. So this is chemistry 101, is understanding this table, what's going on here. Remember the mass number is the neutrons plus the protons. It's usually written at the top, by the way. And unfortunately, they get written all over, actually. They also get written at the bottom right. I'm sorry, that doesn't help. Atomic mass is the number of protons and neutrons. The proton number tells you which atom it is. Usually you'll see each little square in the periodic table look like this. And as an interesting hint that we'll get to later, look at that atomic mass. If protons have an atomic mass unit of 1 and so do neutrons, how do we get an atomic mass that is a decimal? I'll tell you now, it's an average, but we'll come back to that. Okay, periodic table of the elements. Every little square has an atomic mass, which is the number of protons plus neutrons, and then it has an atomic number, which is just the protons. That's all you really had to learn from this BandAid. I think you're doing okay. I'm going to stop this video, and I'll make you another one soon.